Good morning. Today we are going to see eccentrically loaded column, and we have that is axial load and uniaxial moment only. So we do not have in syllabus biaxial, so we will go with uniaxial moment. So we have this was asked in examination. Check the adequacy of ISIB 450 to carry a factorial compressive load of 750 kilonewton at an eccentricity 270 millimeters about major axis. The effective length is given 3 meter. Consider only section strength. This is most important. So we have to go for only sectional strength. So we are going to consider only area and ZP likewise. So compression flange is laterally supported. So we have MD as ZP Fy upon gamma m. So properties of the section D, BF, then TW, TF, RY, A, P, E, and from E we have calculated MZ. So we have mz that is equal to p into e. Then we have zpz 1955.03 into 10 raised to 3. So classification of section as bf by 2 by tf less than 9.4 plastic, d by tw less than 84 web also plastic, section plastic, and beta b is 1. And ae also we have that is equal to ag. Then we have design compressive strength. Now you can see we have this is IS clause. So we have as uniaxial moment. So this term will not be there. So we have N by ND plus MZ by MDZ less than or equal to 1. Now MZ we have that is a moment about major axis. Then we have M and DZ. So we have strength under combined axial force and respective uniaxial moment acting alone. C 9.3.1.2, and we have factorial applied axial force, that is tensile T or compressive P. Then ND design strength in tension TD as obtained from 6 or in compression due to yielding given by. So ND value we have for both as AGFY upon gamma m. So by using this formula, it may be in compression or it may be in tension. It is given by AGFY upon gamma m. And AG we have gross area of the cross section. And then we will go for ND is AGFY upon gamma mo. ND we have A we have 111.14 10 raised to 2, 250 upon 1.1. So it comes 25.91 kilonewton. In design bending strength, we have as laterally, this is laterally supported, and therefore for laterally supported, we have to go by beta B ZP Fy upon gamma mo. And from this, we will get value of MD. 444.33 into 10 raised to 6 Newton millimeter. So 444.33 kilonewton meter. Then check for section strength. We have seen we have this instead of P, I will write it as N by ND, then plus mz by mdz less than or equal to 1. And then we will substitute value p pd then mz mdz, and we will get 0.75 which is less than 1. And as above condition is satisfied, so that column section is adequate for given loads. Then second problem we will have the change we have only, it is laterally unsupported. So we have change that is only for MDZ. Here MDZ becomes beta B ZP into FBD. That change we have only, and therefore first steps we are being as it is. So I need not require to explain these steps. So we have these step as it is, whatever we have in problem 1. And then we have design compressive strength ND we have calculated. Then now this is design bending strength beta B ZP FBD. KL upon RYY we have 57.92. HF upon TF we have that is 31.85. And then we will calculate value of FCRB, KL upon R, and HF upon TF. From this, we will get first value for 31.85 and 50, that is 921.551, and for 60, we will get it as 655.42. From this, for 57.92 KL upon R, we will get FCRB 710.77. And then we will calculate value of FBD For FCRB 710.77, and we will get value of FB, and that is equal to 202.78. And then we will calculate MD from this, and that is beta B is 1, that is ZPZ into FBD, and we will get 396.44 kilonewton meter. And then we will check it for strength. Now again we have that is given, this will be ND, because in some book it is mentioned as actually P, but that P is for your check buckling resistance for compression, and then we have to use scale upon R, and that will not be section strength. So for section strength we have to go N upon ND plus mz upon mdz, and should be less than or equal to 1. So now change we have only here 396.44 we have substituted, and that comes 0.81 less than 1, and therefore above condition is satisfied, so that column section is adequate for given loads. So this is all about your columns, and this completes your unit number 3. So we will stop here only. Thank you.